Welcome to Precision Technologies. This is Venkat. In this video, we'll discuss the use of BackgroundWorker class in Windows Forms application with an example. First, let's look at the application that we'll be building today. So this is the application that we'll be building. So basically it has got process and cancel buttons. When I click the process button, the program is going to compute the sum of the first 100 numbers. Now while the program is computing the sum of the first 100 numbers, it is also going to show us the progress that it has made. Okay, so in terms of percentages, and we have a label control here. The label control is also going to display the percentage. Let's actually look at that in action. I have already built this. So when I click process, notice that the progress bar is moving forward, and here within the label control it's actually displaying the progress percentage. And then once it has reached 100%, look at that, the sum of first 100 numbers is 5050, and that's what is displayed here. Now let's say when I click the process button, it's still processing the sum of the first 100 numbers. If for any reason I want to cancel the processing, when I click the cancel button, look at what happens. First of all, the progress that was made is reverted, and then within the label control it just displays the message saying processing cancelled. Okay, so let's see how to achieve this using BackgroundWorker class. Okay, now, so first of all, let's understand the rationale behind using BackgroundWorker class. So by default, Windows applications are single-threaded. This means when we run the application, there will be a single thread which is commonly called as the UI thread. That is the thread responsible for doing all the work, that is creating and updating user interface elements, repainting them when required, and executing the application code. Now let's say for example we have got a function that takes 10 seconds to complete. While the UI thread is busy processing this function, the UI of the application is frozen and the end user cannot interact with the controls on the form during those 10 seconds. Now, to keep our application responsive, we can create a new thread ourselves and then ask that thread to execute the function that takes a long time to complete, so that the UI thread is free to update the controls on the form. But the problem with creating threads ourselves is that it can get extremely complex, especially when we have to update UI controls based on the status of the thread function execution. Okay, now let's understand what we mean by this last statement. The problem with creating threads ourselves is that it can get extremely complex, especially when we have to update UI controls based on the status of the thread function execution. Now look at this. When we click process, based on the progress that is made, we are updating the user interface elements here. And then once the processing is complete, we are also taking the results from the thread function and then updating the user interface elements. So if we have to do something like that, there is thread synchronization and all that stuff that comes into play, which can make multi-threading a little complex. And another golden rule to keep in mind is that it is dangerous to access UI objects on a thread that didn't create them. Now if you look at this application right here, when we run this Windows Forms application, all these controls are there on the form at the design time. So when we run the application, we get one thread for free, that is the UI thread, and that is the thread that is creating all these controls. And then let's say we are creating another thread, to compute the sum of this first 100 numbers. If that thread tries to access these controls, that can become dangerous in the sense that the behavior of the program can become unpredictable. Okay, so the better option here is to use the BackgroundWorker class, which simplifies multi-threading. So let's see how to use that. Before we look at using the BackgroundWorker class, let's look at the important properties and events that this control exposes. So these are the two properties. Look at that. One property is called worker supports cancellation. Now set this property to true if you want the background operation to allow cancellation. Okay, so if we look at our application here, when we click the cancel button, it's canceling the processing, the background operation. Okay, so if we want the application to allow that, simply set that property to true. And worker reports progress. Again, if you want the background operation to report progress, again set that property to true. Here we are reporting progress based on the progress made when calculating the sum of the first 50 numbers. Okay, so we are going to set those two properties to true, and then these are the events that we are going to make use of. Now, do work event. Okay, so this is the event handler where the time consuming operation runs on the background thread. Okay, so in our example, the code to process the sum of the first 100 numbers will go in this function, in the do work event handler method. And progress changed, so this is the event handler where we write code to update the user interface elements with the progress made so far. So when the application is calculating some of the first 100 numbers, obviously it is doing progress as it's calculating. And if you look at the progress bar and label controls were being updated with the percentage that is completed. So the code to update these user interface elements will go in that event handler method. And then run worker completed, basically, the name itself implies what this means. This do work event handler contains the code to execute the background operation, the time consuming background operation. Once that is complete, this event is raised automatically. And keep in mind, this run worker completed event gets raised for three reasons: when the background worker has completed processing successfully, or when it has encountered an error, or whether, if we have requested it to cancel the execution. So when we click the cancel button, we are requesting cancellation. So even if that's the case, run worker completed event is fired. So this is where we write code to update the user interface elements accordingly, depending on whether we completed successfully, or there was an exception, or did the user request for cancellation. Okay, so let's go ahead and look at it in action right now. So first, let's shift to Windows Forms application here. So if you look at this Visual Studio instance, I have created a new Windows Forms application. I have named it Demo. And then at the moment, what I have done is on the Windows form, dragged and dropped two button controls, progress bar control, and a label control. For the button controls, I have set the name to BTN process for this button and BTN cancel for this button. Okay, so first of all, let's go ahead and drag and drop this background worker onto our form. So when I double click the background worker control, look at that, it doesn't get placed on the form because that's something that the user doesn't see, okay, on the form itself. So it's placed right here, background worker 1. And then let's get to the properties of that. So on the properties window, notice that we have got these two properties: worker reports progress, worker supports cancellation. So let's turn them both to true, because we want to report progress and we want to support cancellation. And then let's also generate the required event handlers. So look at the events: do work, progress change, run worker completed. So double click on do work, it's going to generate an event handler. Similarly, let's go ahead and double click the other two, progress changed, and finally run worker completed. So here we have the respective event handler methods. And then let's also go ahead and generate event handlers for the button process click and button cancel click. Okay, so at this point we have all the event handler methods that we need. Now in do work, what kind of code are we going to write? So this is the code that we are going to write in do work event handler. So basically, this is a very simple code. So if you look at this code here, we have initialized a variable of type integer to 0, calling sum, and then we have a for loop here. I runs from 1 to 100, and then to introduce some artificial processing time, we are making this thread sleep for 100 milliseconds. And then we are saying sum equals sum plus I. So that's the expression which is going to compute the sum of the first 100 numbers. And then this is what is important. So look at that, background worker 1. What is this background worker 1? That is the control we have dragged and dropped onto our form, background worker. Okay, so we are saying background worker 1 dot report progress, and we are passing I. Notice I runs from 1 to 100. and percentage is also typically from 1 to 100. So when it has computed sum of first 10 numbers, I will be 10, meaning 10% has completed. So we are passing that number to report progress method. Okay, so when we call this method, this background worker control is automatically going to raise progress changed event. We will next see in a bit how to handle progress change. So basically here we are reporting progress. Okay, if we have computed the sum of first 50 numbers, then the progress that we are reporting is 50, meaning 50% has been completed. So when we invoke this method, keep in mind progress changed event is raised, and in a bit we'll see how to handle that. And then this is very important as well, because we want the program to support cancellation as well. So this background worker 1 control has got a property called cancellation pending. So if somebody has clicked the cancel button, what happens is this cancellation pending, that turns to true. Okay, so when we are computing the sum of the first 100 numbers, we are also checking, okay, if somebody has requested for cancellation, if that property returns true, then somebody has clicked the cancel button, in which case we want to cancel this work, this operation. Okay, and all we need to do is we are setting cancel property of the e object to true. So what is this e object? This is nothing but the parameter that is coming into this event handler. So do work event arguments. Okay, so here we are setting the cancel property of that object to true. So what is the background worker going to do when it detects that cancel property has set to true? It's going to cancel the background operation. Now when we cancel the background operation, obviously we want to revert the progress made so far to 0. That's why we are calling report progress method and passing 0 as the parameter to that method. So obviously on the UI, this progress will be reverted to 0. Okay, and then we simply return from the event handler method because there's nothing left to do. If no one has requested cancellation, then it's going to come here and look at this. Once the entire for loop is completed, it's going to come to this line and look at again here what we are doing. We're setting the result property of do event arguments object to the total sum. In a bit we'll see how we are going to make use of this result property, and we are also going to see how we are going to handle progress changed event that this background worker raises. So first let's look at progress changed event, and before we do that, I have this exact piece of code already typed within the notepad, so let's copy that and paste that within our Windows Forms application. So right click on the form, let's go to the code page and look at that, do work. Within this event handler, I'm going to paste this exact same code. So thread class is present in system.threading namespace. So let's go ahead and bring that namespace in. Now if you need this code, I will have available it on my blog as well if you want to copy and paste it. Okay, so that is do work. Now let us see how to handle the progress changed event. Now this is pretty straightforward. If you remember on the previous slide, we are calling this report progress method on the background worker. So obviously this is going to raise progress changed event. And if you look at the progress changed event handler, to it we are receiving progress changed event arguments as a parameter. Okay, so this object has got progress percentage property. So this is going to receive whatever number we are passing here. So if we have passed number 10 as the value for I to this method, then progress percentage is going to retrieve that 10, and then look at that, we have progress bar control on the form as well. This is the progress bar control. We are setting the value equal to whatever value that we get into this event handler method using this property. And on the label also we are displaying the actual number, and we are converting that to string and appending this percent symbol to whatever number we get. Okay, straightforward background worker progress change. Again, I have this code here, so let's copy that and paste it within progress changed event. Alright, now the next step is to implement run worker completed. So if nobody has requested, if you look at the previous slide, if nobody has requested cancellation, and if we have looped through the 100 numbers, so obviously we have the sum of 100 numbers, and look at where we are storing it. We are storing it in the result property of do work event arguments object, which then gets passed down to this event handler method. So here, look at what parameter we are getting into this event handler: run worker completed event arguments. And this object has got three important properties: e.cancel, e.error, and e.result. So this result property is going to contain the result that we have set here. Okay, so now we are checking if e.cancel, if somebody has requested a cancellation. Okay, if somebody has requested a cancellation, what did we do? We have set cancel property to true. So that gets passed to this cancelled property of this object. So if it is cancelled, then on the label what we want to display is processing cancel. Else, if there is an exception, so if there is an error, if that is not equal to null, then we know an exception has occurred, in which case we are just displaying the exception message within the label. Else, meaning an exception didn't occur, nobody has requested cancellation, in that case get the result out and display it within the label control. Straightforward. So let's go ahead and copy this piece of code and paste it right there. So far what we have done is implemented the event handler methods of the background worker class. Now we need to call the do work operation somehow so that the background worker can go ahead and execute this time consuming piece of code within the background so that our UI thread is free. Okay, so let's go ahead and see how to do that, how to invoke that. So within button process click, first we are checking, okay, is background worker busy? If it is not busy, then go ahead and execute the do work function asynchronously. That's what this method does, run worker async. Now let's see what's going to happen if we don't have this condition. So if we simply say background worker 1 dot run worker async, so we are going to run it asynchronously, and look at that, I'm not putting any condition there. So if I go ahead and run this now, so this is the application that we are creating. I click the process button, it has started processing. What is going to happen if I click the process again? We are going to get an exception. Why is that? And look at the exception, what it says: this background worker is currently busy and cannot run multiple tasks concurrently. Okay, because the background worker is already doing the processing, and at the same time you're clicking the button again, so it can't run two background operations tasks simultaneously because we have just one instance of background worker class. Okay, so that's why it is important to include that property. If background worker 1 dot is busy, if it is processing, then it's going to return true. If it is not busy, then try to call the do work operation asynchronously. Else probably you can also display a message within the label control stating um, you know busy processing, please wait. So something like that: busy processing, please wait. Okay, and when we request the cancellation, what should we do? The same logic applies. If the background worker is not, if the background worker is busy, meaning if it is still doing the processing, then go ahead and cancel the processing. And how do we do that? We call this method cancel async operation. So cancel async. Okay, now why is it important to check this? If it's not busy, then there is nothing to cancel, so it doesn't really make sense to call that method. So check that property. If it is busy, then cancel the asynchronous operation. Else probably again you can just print a message saying within the label control, there's operation no operation in progress to cancel. Okay, so let's go ahead and run this and see if it works as expected. So click process, so it has started processing. I click the cancel button, look at that, processing cancel. If I click the button again, look at that, no operation in progress to cancel. Now I click process button, I click it once again. Basically that is because it doesn't display that message for a long time here. That's basically because every 200 milliseconds we are updating the status on this label control. So what I'm gonna do here, instead of displaying that message within label 1, which is getting overwritten with the percentage that's completed, let's include another label control and probably display the message within that label control. So let's drag label, another label, and leave it right there. And within the form, we can simply say label2.text equals that. And now we should get to see that. So process, so it's processing. When I click process again, look at that, busy processing, please wait. Okay, and then once the processing is completed, you can set that label text to an empty text so that you don't see that message there. And the way to do that is simply within your do work, when that within your run worker completed, if that has completed successfully, probably here we can simply say label2.text equals an empty string. So let's run this, click process. Look at that, if we click it once again, busy processing, please wait. Once the processing has completed, then it's going to display that 100%, and then it's also going to set the label2 text to empty so that we don't get to see that. I click the button again, it starts all over. I click cancel, processing cancel. I click it once again, no operation in progress to cancel. Alright, hope you enjoyed this video. That's it for today. Thank you for listening. Have a great day.